In this question, different covalent molecules are given. We have to identify the one which possesses a non-zero dipole moment value. Dipole moment is completely based on the electronegativity of atoms present in the molecule. Electronegativity is the ability of an atom to attract the shared pair of electrons in a covalent bond. If an atom is attracting the electron density, they will get a partial negative charge and other one will get a partial positive charge. Now let's come to the options given here. The first one is carbon tetrachloride or CCl4. This molecule has a tetrahedral structure and chlorine is more electronegative than carbon. So we can say the dipole moments are equal in magnitude but opposite in direction. So they will cancel each other. Hence the dipole moment of the molecule will be 0. And the second one is hydrogen iodide, which has a linear structure. Iodine is a halogen and which is more electronegative than hydrogen. As a result, the electronegativity is moving towards the iodine and this molecule is polar in nature. The third one is carbon dioxide. It has a linear geometry. Here, oxygen is more electronegative than carbon and these dipole moments are moving equally but in opposite direction. So the total dipole moment value is 0 in case of carbon dioxide. The last one is BF3 or boron trifluoride, which has a trigonal planar geometry with a bond angle 120 degree. Fluorine is more electronegative than boron and this electron density is moving more towards the fluorine atom. Now here also we can say this molecule will be non-polar, that is the dipole moment is 0. So from these four molecules, the molecule which has a non-zero dipole moment value is hydrogen iodide. Option B is the correct answer.